Hello all, welcome to my YouTube channel PK Chemistry. In the last lecture, we have discussed pinacolone rearrangement, migratory aptitude factor, and also discussed the symmetric and unsymmetrical diols, and also discussed the examples. In this session, we are going to discuss semipinacol rearrangement. Semipinacol rearrangements are rearrangements in which hydroxyl group provides the electron to push the migrating group. At the same time, pull comes from the living group other than water. For example, scientists try to synthesize seven-membered cyclic ketone. For example, ketone from diol. So in the normal case, if you take pinacolone rearrangement in the acidic media, what will happen? This diol forms an oxonium ion and leaves the tertiary carbocation. But in this case, we will not get the expected product. So what will happen? So this goes the another direction. So we'll get the so you will get a aldehyde product. But they needed seven-membered cyclic ketone from diols. To overcome this problem, they used selective tosylation of primary alcohol. So what you will get is hydroxyl and O tosyl. So this hydroxyl group pushes the migratory group. At the same time, the tosylate leaves. So what you will get is the ring expanded product. You will get it in the basic media. If you take another example, so this is diol R2 R1 R1. There are two possible way. OH R1 R1. If you take tosyl chloride, it prepares the less hindered site. So what you will get is, so this gives the electrons, the migration happens, the O tosylate leaves. So the product is R1, R1, R2. This is semipinacol product. If in the acidic media, what will happen? The formation of more stable carbocation. So OH2, so forms the stable carbocation here. The next step, the migration of R2 gives the ketone product. This is phenol product. If you look at these two reactions, In the presence of tosyl chloride, it favors the less hindered side and leads to different product than the normal pinacolone rearrangement. So if you take this diol, so in the presence of tosyl chloride and base, so what will happen? This tosyl chloride protect the hydroxyl group. So basically this tosyl chloride protects the primary alcohol better than the secondary and tertiary. The order is like this. In the presence of tosyl chloride, so secondary hydroxyl group tosylated to give the tosylated product. Then this electron pushes at the same time this bond comes here, automatically the tosylate leaves. So what you will get is 7-membered ketone we will get a 7-membered ketone. We have discussed in the Wagner meerwein rearrangement the carbocation formation. We have, so carbocation formed from halide, alcohol, amine, alkene. We have discussed. If you look at this example, in the presence of silver nitrate, the iodine leaves behind the carbocation. At the same time, this hydroxyl group pushes the migrating group, so result in the formation of ring expanded product. So what you will get is ketone. If you take base, immediately it will form the epoxide. So that's why they used acid to expand the ring. The leaving group need not to be tosylate always. It may be halide or nitrogen. If you consider this NH2, I mean, in the presence of sodium nitrate, you will get a diazonium intermediate. So OH, N triple bond, N plus. This is the intermediate. This diazonium is the best leaving group. This electron pushes to migrate the migrating group. So what you will get is ring expanded product. If you take this example, cyclohexanone, in the presence of diazomethane, so what you will get is OH, N, triple bond, N. The next step is the same migration will happen what we discussed in the semipinacol rearrangement. So this bond pushes the migrating group to push the leaving group. So what you will get is the elimination of nitrogen. We will get the 7-member cyclic ketone. We will discuss some more example. If you take this, amine, presence of nitrous acid. So what you will get is diazonium ion. The next step is elimination of nitrogen. So what you will get is the bond O, phenyl methyl. So another example is, if you take halide in the presence of silver ion, so what will happen? This will goes. First of all, you will get a carbocation. So the next step is migration of our group. So what we will get is ketone product.